Hello all! Some time ago I have released a video about advantages of using Redux, an architectural build based on actions. I still think it's a great and elegant solution, however, I do recognize the flaws. Mainly the amount of code needed to write anything, and how centralized the state is, make it harder to code split. One of the most common use cases I face in application is fetch a list of data, save it in the store, select for displaying. So I've asked myself a question, what kind of solution could I invent that would let me do this with as little code as possible? It would have to be reactive so that if data is changed, it is reflected in the UI. Also, platform agnostic, so I could use it in React, Angular, or even Vanilla.js. To achieve that, I've settled on using RxJS as a base. This means that Reactive State is essentially an extension built on top of RxJS. Another matter I want to address is how we view state in our applications. In case of Redux, it is basically a single blob object. If you are using something like Zustand, you may end up with multiple smaller blobs, but blobs nonetheless. In my solution, I have settled on small units of state. You have variables, maps, sets, arrays, all standard data structures, but reactive. I have prepared a simple demo application with a list and details view. Additionally, on the side, we have cards displaying which items are currently being fetched, deleted, or updated. Red X and green checkmark indicate if the request for that given product will fail or succeed. As I paginate forward, I am fetching a new data. It is indicated in the fetching card in here, so let's do it again. And we see that pagination happens. If I go back, then I am having the data served from this state because it's already cached. If I click on the individual item, it is also served right away because it's cached. You get some control over that caching mechanism. Pages in pagination are set to last 5 minutes. Additionally, strategy is set to eager, meaning that if data is invalid, you will see loader, and the data is served when it's fetched. Invalidation scope is all, meaning if I catch one page that is invalid, I invalidate all of them because I see them as correlated, so it makes sense to fetch them anew. Individual items have also set invalidation timeout to 5 minutes, but strategy is set to lazy, meaning that if the data is outdated, you will be served the old data first, and the new data will be downloaded from in the background. And the scope is set to single, meaning that if only one item we are requesting is invalid, we are only invalidating that one item, all the rest are left as they are. Now I have changed the timeout on the individual items to 0. So when I go back here to the list and I click again on that item, you will see it's being served, but in a fetching, we see that this item is actually being fetched in the background and updated behind the curtain. So let's do it again, also with Nissan. Yep, it's being fetched. So yeah, so we get a lot of control over how the caching works. We are back with the original settings, so 5 minutes. Now I want to show you updates as well. So we click in here, we change the price. You notice that the price will change here and we will see the updating ID in here. So I click submit, it's updating, and the price is changed. Now when I go back to the list, the value is also updated in here. With Reactive State, it's also easy to perform optimistic updates. For those of you who do not know what it is, an optimistic update is an update that will reflect in our UI before we get confirmation from the server. You'll notice two bin icons next to the items, so this one and this one. The first one performs standard update, so it will just wait for the confirmation from the server to update UI, and the second one is optimistic one, so it will update UI before getting that confirmation. So let's see this one, we are deleting, and once deleted, we update the UI. And the second one, we click on this bin icon, it's deleting in here, but the UI was updated before we got our response from the server. Trying to delete a failing product would result in an error. Let's see the difference between standard and optimistic delete. Standard delete will not update UI, but if we do optimistic delete, you remove that from the UI, but when you got the error from the server, we restore it. I have also decided to invalidate all pages on item delete. So if I navigate, I'm fetching data anew. So you can see here I'm navigating the next page, and when I go back, I am also getting that data. And now it's already cached. So this is for the presentation. Let's see the code now. Here we have defined our product store with query behavior subject that keeps the data about the last query. We have deleting, updating, fetching, reactive sets, which keep the keys of the items that are under some action. We have entities reactive connect map, which is a map that keeps individual items. Here we are passing optionally fetching set, so that if something is connecting, it's updated here automatically in our settings. And the last we have queried. This is reactive connect arrays, which is a construct that keeps the paginated data. So in here, additional to the standard options, we pass items map, which is a reactive map that keeps individual items, and item key, which is a function to retrieve the key of that individual item. Next, we have service in the constructor. This is the class used to make HTTP calls. Connect method to retrieve an individual product. It takes key as the first argument and a callback to retrieve data in the second. Update method to, update data. First, we add product key to updating set. Then we call service patch method to make an HTTP call. On the success, we update entity using entity set and remove the key from updating. In case of error, we only remove the key from updating. Here in product details route, we import product store, get product ID from the URL. We use the useStream hook to unpack pending stream. We get a result that can be status of pending, error, or success, and we handle them all. Back in the product store, we've got connect query method. We create a page key by combining limit and skip from query into string. We update query behavior subject, and we call queried connect method, which will return data from state or fetch it using past function. Last in product store, we have delete and delete optimistic methods. In the delete, we add key to deleting. We make an HTTP call to delete data. On success, we delete entity, remove key from deleting, and manually invalidate all the pages. In case of error, we simply remove key from deleting reactive set. Delete optimistic is similar. First, we retrieve all data from the state. Then immediately we remove the entity. We add key to deleting just like before. On success, we remove that key and invalidate all the pages. We do not need to delete entity anymore because we did it upfront. In case of error, we remove key from deleting and restore deleted entity using entity set with all data. In the products list route, similar to the product details route, we get a query from the URL, get result using useStream hook, and handle possible outcomes. In the product list item container, this here, we use the useStream value to unpack stream. This hook is designed to work with observables that always emit and never throw. We get deleting Boolean value for the selected product. We define onDelete and onDelete optimistic methods to handle those scenarios. And that's it. Updates happen automatically whenever observable emits a new value. useStream and useStream value hooks are optimized to cause as few renders as possible, but you can test it for yourself. I will leave links to the Reactive State and React Utils packages in the description. I especially recommend reading through the README of the first one, as I describe there in more detail what data structures are available and what connect options do. I also leave the link to the repository so you can play with the demo application yourself. Also, I know I have troubles pronouncing observable well under pressure, but I will try to do a better job next time. Thank you.